Welcome to H2K Infosys. H2K Infosys is a e-verify business based in Atlanta, Georgia, United States. We provide 100% job-oriented, instructor-led, face-to-face, true live online software training programs. It also includes access to cloud test lab with software tools. We provide live project for you to work on. We also provide assistance with mock interviews, resume preparation and review, and job placement assistance. H2K Infosys is trusted by so many students across the world. H2K Infosys provides world-class services in IT training with real-time project work for corporates and individuals, special IT training for MS students in the United States, software design, development, QA manual and automation, performance testing and maintenance, IT staff augmentation, job placement assistance, and tech support.
If you guys remember, during the first class, we have discussed about Java features, and we have mentioned about multi-threading is one of the most prominent feature of Java. So did you guys get a chance to verify what is the purpose of call stack, or what kind of objects, so what kind of variables or members will go to stack level or heap level memories?
Yeah.
Did anyone verify?
Yeah. I verified.
Okay. See, from next day onwards, please verify your emails and make sure that you're going to that particular topic before coming to the class. So we are almost done in the core Java, only 3 or 4 topics left. Probably by next week, we'll be going to complete the core Java. So you should be good enough to understand some of the concepts which we haven't discussed in the class. But I'll make sure that you guys are aware of those topics before attending the class. But all that you need to do is verify my emails and go through those topics before attending the class. I'll explain briefly what kind of members will go to stack or what kind of members will go to heap. Currently, we are talking about the JVM, Java Virtual Machine, and the JVM memory allocated for that. As you can see, I have opened Eclipse here. So by default, it will start Java W, the .exe file. If you go and verify your task manager, you can see that Java w.exe file. And this is occupying 453 MB. Normally, Eclipse will get 512 MB as RAM memory for JVM memory allocation. So that 512 MB memory is used to create your objects. In the sense, whenever you have executed any code, when you create any instance of an object, or when you call any method, the local variables, or the instance variables, or the method calls, those are all supposed to be created within 512 MB memory only. So we have already discussed about garbage collection, which will verify the unused objects in the memory, and it will be going to reclaim that particular memory space. Whenever I have created any object in the JVM representation, normally I'll create the object inside this particular memory space, and I'll create the reference variable outside the memory space. this entire part is actually the JVM memory space only, but it was divided into two parts. The first one is heap memory and the next one is stack memory. Stack memory is where your local variables and references for the objects will reside. So that is at this level. That's why I'm specifying all the reference variables outside. If this is an object, so in our current case, this is our order object, which consists of two variables, instance variables, order ID and item code. And this is our order object, which is nothing but our superclass reference. Objects, all objects will get created on heap memory. And all variables, all local variables and references will get created on stack memory. Whenever you call methods, let us say from your order demo is also a class which starts with a method called main method. Whenever you call a method, it will be placed on the stack main method, and it will start executing the code. So this way it will start executing, and when it sees that you are creating a new object, that means it was supposed to call that particular constructor. And here you are calling this print info method on that particular order object. Forget about constructor calls and all. The next method that will be called from our main method is print info method. So at this time, the print info will be placed onto the stack. Stack is nothing but last in, first out. If you guys comfortable about the data structures, stack specifies last in, first out. So the next method will get onto the stack is print info method. Whatever the local variables that are available inside the method. So currently our print info, go to our print info method. Let us say if you declare some local variables into data. So this local variable will reside at the same level. So that means the variable will get created at this level. But if you refer any object, let us say you are referring to change order object. Just for understanding, I'm creating. When you create an object, the object will get created on the heap. So this is the heap memory. The object will get created here, and the reference variable still it will be available on the stack, and this will be going to point to this particular one. Whenever the print info method has completed, so completed in the sense whenever the method execution or the closed brace has reached, this will get removed from the stack because the method execution has completed, and all the local variables like ch order, data, and these will get destroyed immediately. Local variables are only accessible, or their lifetime is only within the method. Whenever the method has destroyed, or whenever the method code has completed, all the local variables will get destroyed. So currently this method execution has completed, but still this object is in heap, because objects, they won't get destroyed even though if they have created in the local in the method as local variable. So currently this object is not referred by any reference variable, and this object is available for garbage collection. Once after executing this method, execution has completed, this will return the control this will return the control back to the caller, which is our main method. Even though if you have plenty of methods going in chain, it will get created onto the stack, and this entire stack is called as normally called stack, because it consists of, or it maintains all the method calls, and it will contain the pointers where exactly it was supposed to return the call or return the control once the method code has completed. Let us say this method code has completed, and there should be a pointer. Come back to our auto demo. There should be a pointer which specifies that previously the execution from main method has stopped at this particular place. So your main method call, which was available on the call stack, it will specify those details, and the control will be transferred back to the same level, and the execution starts from the same place. Currently, we just need to understand what is meant by call stack. If you guys need some additional information, just go through Google and identify some other information. But from next time onwards, please go through the topics, whatever that I have sent in email. Is there anyone asking questions, or I couldn't able to hear their voice? Multi-threading.
Krish, can you hear me, Krish? Soumya here?
Yeah. Yes, Soumya.
Okay. I just logged in through phone. I just wanted to check if you can hear me. Thanks, Krish.
Yeah. Multi-threading, one of the basic feature of Java. Before going into multi-threading concept, we just need to memorize some concepts like what is meant by multitasking or multiprocessing. We are already familiar with multitasking because currently whenever we'll use Windows machine, here in my system also you can see that I'm using multiple tasks. I have opened Google Chrome and Eclipse and the document, folder, images. So these are the 5 tasks that are working parallelly on my Windows machine. If you go and take a look at the task manager, for each and every application you have opened, it will create a separate process ID, and it will be going to allocate some memory space for that. You can see that the physical memory that was required for each and every application to work properly. And the CPU processors, you can see that 106 processors are available. The multitasking, nothing but your CPU cycle will get shared between different applications. As you can see, all the processors are working parallelly, but your CPU will be going to switch between the applications or between the tasks. Multiprocessing. If you take a Unix machine will consist of set of groups or users, and which consists of usernames and passwords, and based on the group or based on the username, admin user or normal user or root user, anybody can log in at the same time and work on the same machine. But ultimately, the commands will get executed at the central place, which is at the kernel level. But here, Java also thought that if at all, if we have implemented such type of scenario with respect to the programming language, that will help a bit instead of wasting CPU cycles. CPU cycle, see, to execute our program, whenever we are running our program, you can see that it is executing the program. But before executing the Java has to get a CPU cycle from the underlying OS. Then only it can start and execute the program. Once it got the CPU cycle, Java knows or JVM knows that how to execute the file or how to convert the instructions into machine readable format and execute with respect to underlying machine. But let us say, take an example. We are working on a program where we want to read the data from a input resource. We haven't covered any streams kind of stuff, but just understand this like a basic information. We just want to read from our Java code from an input resource, or let us say we want to read some kind of information from an external system, and we don't know when the input stream will be available for us to read the content. So what we are supposed to do, we have to start executing our program. And we need to wait. We should be in waiting status because we don't know when the client will be going to send the data from the input resource stream. But here, when you say we should be in waiting status, you are holding the CPU cycle. See, you got the CPU cycle for your JVM to execute the program. You won't get each and every time. There will be turns. Your CPU will decide, or your underlying OS decide, yeah, now I'll hand over the CPU cycle to the document. Now I'll hand over the CPU cycle to JVM. Or else if you are printing some information, it will hand over the CPU cycle to that. But you will feel that all the programs or applications are executing parallelly, but it will switch. It will switch from one application to another application within a fraction of nanosecond. Switching from one application to another application or one task to another task, in terms of programming language, it will be called as context switch. So here, you got the CPU cycle for your JVM, but what you have done, you are asking the JVM or you are informing to wait for a certain period of time or until the information has received on the stream. But what we are doing here, we are wasting the CPU cycle which got allocated for us. That's where the thread concept came into the programming language. Thread is nothing but a separate path of execution. Separate path of execution in the sense, when you start main method, say main method is the starting point for any Java program. When you start in this way, so the program execution starts from top to bottom, and at some point you have mentioned that you are supposed to wait until the input stream has reached or input stream was available. So at this point of time, if you make use of a separate path of execution, so one thread, one path will be going to wait for the input stream, and you can create a separate path instead of your CPU cycle, instead of wasting your CPU cycle. So whenever a resource or whenever a particular thread is in waiting status, you can ask some other thread, or you can inform JVM that work on some other thread. Let us take one more example, stocks example. If you guys are aware of stock scenario, selling or buying, all the stock brokers, they will get information from stock market, the up-to-date analysis or up-to-date information. With each second, they are supposed to retrieve the information from stock market. And at the same time, they are supposed to display the data to the users, because the client wants to verify the up-to-date value and he wants to place some orders. Orders in the sense either to sell the stock or either to buy the stock. If you say perform the information retrieval from the stock market and then display the data to the client, that means it will take some time to execute that particular code and information displaying to the client. So by that time he displays the information to the user, the stock value, again, it might change and he'll be showing some bad data to the user. So here, if we follow a single thread approach, whatever that we are doing currently, which is executing from the top to down approach, this won't work properly. Sometimes the client may place some orders, like he can place some conditional orders, like if at all, if the value reaches to 10, sell the stock, or if the value reaches to some other stuff, buy the stock. So these are all automatic orders which needs to be executed whenever the value was reached to 10. So whenever he has retrieved this information, at the same time, he was supposed to display the information to the user. And whenever some orders got placed by the user, those are all supposed to be executed. And at the same time, he needs to take care about the conditional orders based on the stock value. So that means there is an interaction required between these two places, either at this level, information retrieval level, or order placing level. You can specify that I'm following a single threaded approach and I'll do one by one, which is not at all a good solution, because the value might change when you are trying to place an order if you follow a single threaded approach. So here, normally, what they will do is they will create multiple threads, nothing but separate paths of execution, and it will be going to collaborated or communicated between the two threads and identify whenever the value of BAC has reached 10, when it has retrieved the BAC value as 10, it will immediately inform to this particular thread, hey, I got the BAC value as 10. If you have any orders, just go and place those orders immediately. So the communication is required between these two threads. We'll see how to place the inter-thread communication and all later, but currently for our understanding, I'm just explaining a scenario. Multi-threading, which is nothing but a separate path of execution. In Java, each and every program execution will also started by a thread only. That is called the main thread. As of now, we have mentioned that our program will get started with executing main method. this main method, usually who will execute this main method? Our JVM will execute this main method. But at the inner level, before it won't directly execute the main method, what it will do, it will create one thread, which is main thread, and then it will call main method by using that thread only. Normally, your main thread is the starting point, and it's also should be your main thread, which is at the starting point because that was spawned by your JVM. And even though if you create any number of threads, your main thread should be the last one to terminate. By using main thread, you can create any number of child threads. We'll see later how to create a child thread. Once a main thread has created, you won't be able to see how it got created because it will be going to be created by your JVM. But once it has created and started the main method, so as of now, only one thread is running, which is main thread. But you have the option of creating child threads by using your main thread. To create any thread or to create any child threads, you need to use a class called java.lang.thread class. Java.lang.thread class. Thread is the class name and java.lang is the package, which is the default package. By using this class, you can create any number of child threads. That means you are providing a separate path of execution for your child thread. Until now, we are specifying about separate path. Separate path, nothing but let us go and verify your main method itself. JVM starts executing main method and it will complete the execution with the main method only. That means whenever the method or the control has reached the end of the statement, end of the curly brace, the main method got completed and your thread will be going to terminate it. So main is the starting point and end point for your main thread. In the same way, for each and every child thread, there is one another method, which is run method, is the starting point. And once the run method has completed, your child thread will be terminated. Just like main method, main thread, run method is also the starting point for child thread. As of now, we have mentioned about main thread, which was created by JVM. So can we get some information about main thread? Yes, we can get information about any thread by using a static method called current thread, which is available in thread class. I mentioned that this is a static method. That means I'm not going to call this on any instance. When you say thread dot current thread. This line was supposed to be executed by a thread only. Either it can be main thread or child thread, wherever you have written. This line was executed by main thread in our case. Let us say you have written at this level. So this level, if you have written at this level, all these lines are executed by your main thread only. That means this particular line also will get executed by your main thread. And this thread, this method call will provide information about the current thread on which it was called. So currently this was called by the main thread, and it will provide information about that particular thread only, and the return value is a thread class, thread object, I'm sorry. When you call this one, this line will be executed by a thread, and the return value on the return, it will be going to provide information about that particular thread. So this is very important one when you enter into threading programming, because you need to know which thread is executing that particular method or code. Once you have created, yeah.
Where will you be executing this particular statement, the current thread?
Main method. I'll show you.
Yeah, when multiple threads are running.
No, 1 second. We'll talk about remaining threads later, but first of all, we're discussing only about main thread. Okay. So once you have created, let us go and take a look at. I'm creating a package, com.threads. One example for main thread. Public static void main, I need that.
So many of our students have given testimonials on how our training programs are. You will find them on kudzu.com and on our website H2KInfosys.com. On our website H2KInfosys.com, you will also find more detailed information on who we are, the courses that we offer, what each course covers. Also, if you're interested in a demo program, please register on our homepage on the left-hand side. Just give us more information about yourself and we will send you a link for a demo class. The demo class is absolutely free. Experience our commitment by just attending an orientation workshop at no cost. Our team of faculty and advisors are here to guide you with the right information. If you still have more questions, please feel free to call us. Call us at 770-777-1269. This is a United States number. If you're calling from the UK, call us at 020-337-17615. You can also email us at training@h2kinfosys.com or h2kinfosys@gmail.com. Thank you for watching our videos. We wish you a great career in information technology.